definition of the neutral conductor is generally accurate. In a three-phase electrical system, the neutral conductor is the common point where the three phases are grounded, usually at the transformer secondary or the generator neutral point. A grounded conductor is a conductor that is intentionally connected to an electrical ground reference, typically earth ground. In electrical systems, white or gray conductors are typically used for the following purposes. In a split-phase or three-phase system, the white conductor is typically used as the neutral. In a single-phase system, the white conductor is typically used as the grounded conductor. It is technically accurate to refer to the white or gray conductor installed to a device or lighting fixture as the neutral conductor if it is connected to the grounded junction point of the electrical system. The term neutral pertains to the specific conductor that is grounded, not to the grounded conductor in general. The white or gray conductor can be referred to as the neutral in most cases, as it is typically connected to the neutral busbar within the electrical panel. However, it is important to verify the actual connection and function of the conductor before making this assumption. Let's delve a bit deeper into the concepts of neutral and grounded conductors, particularly concerning their roles and how to identify them within electrical systems. We should explore the nuances that dictate their usage and clarify some common misunderstandings. Firstly, the neutral conductor serves a critical function in electrical circuits, particularly in alternating current, or AC, systems. Its primary purpose is to provide a return path for current, allowing the circuit to be complete. This return path is essential for the proper operation of electrical devices and equipment. The neutral is generally connected to the system's grounding point, often at the service entrance or the transformer supplying the power. This connection to ground helps maintain a stable voltage level and provides a reference point for the electrical system. Secondly, grounded conductors also play a vital role in electrical safety. A grounded conductor is intentionally connected to the earth, creating a low impedance path for fault currents. This connection to ground ensures that in the event of a fault, such as a short circuit, the fault current will flow safely back to the source, tripping a circuit breaker or fuse and disconnecting the faulty circuit. This process protects individuals from electric shock and prevents damage to electrical equipment. In many residential and commercial electrical systems, the neutral conductor is also used as the grounded conductor. This means that the neutral wire is bonded to ground at the service entrance, creating a single point for both current return and fault current protection. However, it is crucial to understand that the neutral and grounded conductors are distinct entities, even when they are connected together. The neutral conductor carries current under normal operating conditions, while the grounded conductor only carries current during a fault. The identification of these conductors is typically achieved through color coding. In North America, the National Electrical Code, or NEC, mandates that the neutral conductor be identified by a white or gray insulation. This color coding makes it easy to distinguish the neutral from other conductors, such as the hot or phase conductors, which are typically black, red, or blue. The grounded conductor is also required to be identified by a specific color, which is typically green or bare copper. These color codes are essential for ensuring safe and proper wiring practices. Now let's address the specific question about whether it is correct to refer to the white or gray conductor installed to a device or a lighting fixture as the neutral. In most cases, it is indeed accurate to call the white or gray wire the neutral conductor. This is because, in standard electrical systems, the white or gray wire is connected to the neutral busbar within the electrical panel, which is, in turn, connected to the system's grounding point. However, it is essential to exercise caution and verify the actual connections before making this assumption. There are situations where the white or gray wire may not be used as the neutral conductor. For example, in some older electrical systems, the white wire may have been used as a switch-top wire. This practice is no longer permitted by the NEC, but it is still encountered in older installations. In such cases, the white wire would not be connected to the neutral busbar and would not function as the neutral conductor. Another situation where the white or gray wire may not be the neutral is in a three-way switch circuit. In a three-way switch circuit, two switches control a single light fixture from different locations. One of the wires connecting the two switches is called a traveler wire, and it may be white or gray. In this case, the white or grey wire would not be connected to the neutral busbar and would not function as the neutral conductor. To ensure proper identification of the neutral conductor, it is always recommended to use a multimeter to test the voltage between the white or grey wire and ground. If the voltage is 0 volts, then the wire is likely the neutral conductor. If the voltage is 120 volts or some other value, then the wire is not the neutral conductor and should be investigated further. It is also essential to follow all applicable electrical codes and regulations when working with electrical wiring. The NEC provides detailed requirements for the installation and identification of neutral and grounded conductors. Adhering to these requirements ensures the safety and proper functioning of electrical systems. In summary, the neutral conductor is a critical component of electrical circuits, providing a return path for current and maintaining a stable voltage level. The grounded conductor provides a low impedance path for fault currents, protecting individuals from electric shock and preventing damage to electrical equipment. The white or grey wire is typically used as the neutral conductor in standard electrical systems, but it is essential to verify the actual connections before making this assumption. The NEC provides detailed requirements for the installation and identification of neutral and grounded conductors, and it is crucial to follow these requirements to ensure the safety and proper functioning of electrical systems. Now let's expand on the practical applications and potential issues related to neutral conductors. One common issue that arises is a broken or loose neutral connection. This can lead to a variety of problems, including voltage fluctuations, flickering lights, and even damage to electrical appliances. When the neutral connection is compromised, the voltage in the circuit can become unbalanced, causing some devices to receive too much voltage while others receive too little. This can result in erratic behavior and premature failure of electrical equipment. To prevent these issues, it is essential to ensure that all neutral connections are tight and secure. This includes connections at the service entrance, within the electrical panel, and at individual devices and fixtures. Regular inspection and maintenance of electrical connections can help identify and correct potential problems before they cause significant damage. Another important consideration is the proper sizing of the neutral conductor. The NEC specifies minimum requirements for the size of the neutral conductor based on the expected load. If the neutral conductor is too small, it can overheat and potentially cause a fire. In general, the neutral conductor should be the same size as the hot or phase conductors in a circuit. However, in some cases, such as circuits with a high proportion of nonlinear loads, the neutral conductor may need to be larger than the hot conductors. Nonlinear loads, such as electronic devices with switching power supplies, can generate harmonic currents that flow in the neutral conductor. These harmonic currents can cause the neutral conductor to overheat, even if the total load is within the circuit's ampacity. To address this issue, the NEC requires that the neutral conductor be oversized in circuits with a significant amount of nonlinear loads. The specific requirements vary depending on the type and amount of nonlinear loads, so it is essential to consult the NEC for detailed guidance. In addition to sizing, it is also important to consider the material of the neutral conductor. Copper is the most common material used for electrical wiring, but aluminum is also used in some applications. Aluminum is less expensive than copper, but it has a lower conductivity and is more susceptible to corrosion. When using aluminum conductors, it is essential to use connectors and terminations that are specifically designed for aluminum. These connectors are typically made of aluminum alloy and are coated with an antioxidant compound to prevent corrosion. It is also important to follow proper installation practices when working with aluminum conductors, such as applying the correct tightening torque to the connectors. Another aspect to consider is the use of ground fault circuit interrupters, or GFCIs. GFCIs are devices that detect small imbalances in the current flowing through the hot and neutral conductors. If a GFCI detects an imbalance, it will quickly trip the circuit, disconnecting the power and preventing electric shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electric shock. GFCIs are effective at protecting against electric shock, but they can also be nuisance tripped by harmonic currents or other electrical noise. To minimize nuisance tripping, it is important to use high-quality GFCIs and to ensure that the electrical system is properly grounded and wired. Furthermore, when working with electrical systems, it is essential to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and using insulated tools. It is also important to de-energize the circuit before working on it and to verify that the circuit is de-energized using a multimeter. Electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable working with electricity, it is best to hire a qualified electrician. They have the knowledge, skills, and equipment to perform electrical work safely and properly. Electrical systems are complex and require careful attention to detail. Understanding the function of neutral and grounded conductors is essential for ensuring the safety and proper functioning of electrical systems. By following the guidelines and recommendations outlined in this narration, you can help to prevent electrical hazards and ensure that your electrical system operates reliably and efficiently. Let's delve into specific wiring configurations and scenarios where the neutral conductor's role becomes even more critical. One such scenario involves multi-wire branch circuits, or NWBCs. An NWBC is a type of electrical circuit that shares a common neutral conductor between two or more hot conductors. This configuration can save on wiring costs and reduce the number of circuit breakers required in an electrical panel. However, MWBCs require careful wiring and grounding to ensure safety. In an NWBC, the hot conductors are connected to different phases of the electrical system, typically 120 volts apart. The neutral conductor provides a return path for the current flowing through both hot conductors. If the loads on the two hot conductors are balanced, the current in the neutral conductor will be minimal. However, if the loads are unbalanced, the neutral conductor will carry the difference in current between the two hot conductors. It is crucial to ensure that the neutral conductor is properly sized to handle the maximum potential imbalance in current. If the neutral conductor is undersized, it can overheat and potentially cause a fire. Another important consideration for MWBCs is the use of a common trip circuit breaker. A common trip circuit breaker is a type of circuit breaker that trips both hot conductors simultaneously. This is important for safety because it ensures that both hot conductors are de-energized if a fault occurs on one of the circuits. Without a common trip circuit breaker, it is possible for one hot conductor to remain energized even if the other one has tripped, which can create a dangerous situation. In addition to MWBCs, the neutral conductor also plays a critical role in three-phase electrical systems. In a three-phase system, there are three hot conductors that are 120 degrees apart. The neutral conductor provides a common return path for the current flowing through all three hot conductors. Three-phase systems are commonly used in commercial and industrial applications to power large motors and other heavy equipment. In a three-phase system, the neutral conductor is typically grounded at the service entrance. This grounding provides a reference point for the electrical system and helps to stabilize the voltage. It is important to ensure that the grounding connection is properly installed and maintained to prevent voltage fluctuations and other problems. Another important consideration for three-phase systems is the potential for harmonic currents. As mentioned earlier, harmonic currents can be generated by nonlinear loads, such as electronic devices with switching power supplies. In a three-phase system, harmonic currents can cause the neutral conductor to overheat and can also interfere with the operation of other electrical equipment. To mitigate the effects of harmonic currents, it is important to use harmonic filters and to ensure that the electrical system is properly grounded. Harmonic filters are devices that are designed to reduce the amount of harmonic currents flowing through the electrical system. They work by creating a low impedance path for the harmonic currents, which diverts them away from the neutral conductor and other sensitive equipment. In addition to these specific wiring configurations, the neutral conductor also plays a critical role in ensuring the safety of electrical appliances and devices. Most electrical appliances and devices are designed with a 3-wire power cord, which includes a hot conductor, a neutral conductor, and a grounding conductor. The grounding conductor is connected to the metal chassis of the appliance and provides a low impedance path for fault currents. If a fault occurs within the appliance, the fault current will flow through the grounding conductor back to the source, tripping a circuit breaker or GFCI and disconnecting the power. This protects individuals from electric shock and prevents damage to the appliance. It is important to never remove or bypass the grounding conductor on an electrical appliance. Doing so can create a dangerous situation and increase the risk of electric shock. If you are using an older appliance that does not have a 3-wire power cord, it is recommended to have it rewired with a 3-wire cord and plug. This will ensure that the appliance is properly grounded and that you are protected from electric shock. In conclusion, the neutral conductor is a vital component of electrical systems, playing a critical role in both safety and performance. Understanding the function of the neutral conductor and following proper wiring and grounding practices is essential for ensuring the safety and reliability of electrical systems. From multi-wire branch circuits to 3-phase systems and the grounding of electrical appliances, the neutral conductor is a key element in the safe and efficient distribution of electrical power. Always consult with a qualified electrician for any electrical work to ensure that it is done safely and in accordance with all applicable codes and regulations.